All right, today we are doing 6.1, and in chapter 6, we're going to start exploring some inverses of functions. Okay, so by the end of today, you're going to be able to add, subtract, multiply, and divide functions. We're going to write and evaluate what are called composite functions. Okay, so that should be something brand new for you. Okay, so the first part we're talking about, the operations, that's going to be pretty simple. I think you guys will catch on to that very quickly. Okay, and you are given a value for f of x, and you are given a value for g of x. You have to find your given function. Sorry, did I not? You guys need another minute to get that written down. The add, subtract, multiply, and divide functions, and then we're going to write and evaluate what are called composite functions. Okay, so you are given a value of f of x, the function, and g of x. So the notation is really what's going to be new, okay? So if you see f plus g of x, what that means is you are adding those two functions together. If you see f minus g, and then, so you probably noticed me saying it's of x. It does not mean times x. Okay, so the way that you read this is f plus g of x. So you would add your f of x and your g of x functions together. And if it's minus, you do f of x minus g of x. Okay, so I want you guys to try to do the first one. So you are just going to plug in the function for f of x. So think about what your f of x is and what your g of x is. Okay, and then we are just going to be adding those together. Okay, if you're unsure how to get started, we are just plugging in this function, and we are plugging in the function of g of x, and then all we have to do is combine like terms. So we only have 4x squared, we have 3x plus 6x to get 9x, and then negative 1 plus 2 is going to be a positive 1. Okay, and then when you're doing this, of course, you still want your solutions in standard form. No, that's something different. So this is f. Did you say plus? Did you say f plus g of x? Oh, okay.
So would that be multiplied?
Yeah, we'll get there. When you're doing the minus, this is one thing you have to be careful about. Okay, so if you are subtracting g of x, and it is not a monomial, if it's more than one term, you have to make sure that you distribute that negative to everything in g of x. So if there is a minus in front, okay, you can put this in parentheses so that you remember to distribute. Okay, negative 6x minus 2. And then instead of writing all of that out again, I usually just underline my like terms. Okay, so I have 4x squared, 3 minus 6 is going to be negative 3. And then negative 1 minus 2 is going to be negative 3. Okay, so that will be your final answer.
You have to write like f plus g, or f minus g of x.
Nope, you can write it like that. That's fine. Okay, for the next example, you are given a different value for f of x and g of x, and you are also given an h of x. you have to find each function. Something else you will see that isn't said here is not only will you have to find each function, you are going to have to list if there are any restrictions to the domain. Okay, so it'll say list your restrictions, and what that means is if your domain isn't all real numbers, you are going to have to identify the values for x that are prohibited. Okay, so for the first one, this fg just means you are going to multiply them together. So f of x times g of x. So for this one, your f of x is a trinomial, g of x is a binomial, so you are going to have to distribute. Okay, so we're going to distribute 2x to everything and then negative 3. Okay, so try that for part A. Okay, and then Riley, when you distributed did you distribute the 2x to everything? Okay, can you tell me what you got for the first row? Good. Okay, and then Hudson, did you distribute the negative 3 to everything? Okay, can you tell me what you got for that row?
I got negative 8x squared plus 3x plus 36.
Good. All right, so then this is going to be your final answer. Okay, and then for B, you have division. So this is the same thing as f of x divided by g of x. So when you have a function like this, there's no restrictions, your domain is all real numbers. So if your domain is all real numbers, you don't have to worry about listing those. Remember that when you're looking for restrictions to the domain, do you guys remember what type of things we have to watch out for in the domain? You can't have what? With something with fractions, what can you have in a fraction? We simplify the radicals. There's something with radicals too. What can't you divide by? 0. So you can't have 0 in the denominator. And then with radicals, you just can't have a negative because that makes it imaginary. Okay, so those are a few of the things we're going to work on today. So if you have division for B, I'm just going to partition that off. You have 6x squared minus x minus 12. Okay, you could do long division, but you don't have to for this one. Okay, because you can factor. Okay, so if you have a trinomial on top, we're going to try to factor that. Sometimes it may factor and sometimes it might not. Okay, so when you're trying to factor something like this, it might cancel out with something on the bottom. See how this starts with a 2x? So when I'm guessing and checking, because I don't have any GCF or a special pattern, I'm probably going to start with my 3x and 2x because I want to see if these cancel. Now that's not going to work all the time, but it is a good way to get started. So if I were to put a negative 3 here, to get to negative 12, I'd have to multiply negative 3 by what? Positive 4. Okay, so let's see if that works. So 4 times 2 is 8. Negative 3 times 3 is negative 9. Negative 9x plus 8x is negative x. Yay, that works out. So when you're dividing, okay, there are parentheses around the numerator and the denominator, because in your order of operations, you have to do the numerator before you can divide by the denominator. Okay, so this quantity, 2x minus 3, would divide and make what number? Anything divided by itself is what? 1. Okay, so your final answer for this would be 3x plus 4. Okay, but there would be a restriction. Anytime there's a fraction, okay, the denominator cannot equal 0. Okay, so even if it simplifies into something with all real numbers, you have to make sure that you include your restriction there. So if your denominator can't equal 0, that means 2x minus 3 can't be 0. Okay, so you set that equal to 0 when you solve. So if you add over 3, divide by 2, this is going to be your restriction. Okay, so what we would say is your answer is 3x plus 4, where x cannot be 3 over 2. Okay, so the only time you're going to have to worry about the restrictions is if you have that division or if you had a fraction with a variable in the denominator. Okay, so I want you to try part C and part D. Okay, and then you guys can check to make sure that you FOILed correctly. -3 and -8 is -11x. Okay, and again, your domain here is all real numbers, so there's going to be no restriction. Okay, for the last one, there is going to be a restriction. So this is the same thing as h of x over g of x. Okay, your h of x is a binomial, x minus 4. So is g of x, 2x minus 3. There's nothing to divide here. You can't simplify it. You can only do the simplification if your degrees here, this degree is greater than this one. So if you have a trinomial and a binomial, or you can factor and cancel. So if you cannot reduce this, you are just going to leave it as x minus 4 over 2x minus 3. Okay, so you aren't doing any sort of long division there. Okay, and then we know that the restriction is that the denominator g of x cannot equal 0. So if the denominator cannot equal 0, we're going to set it equal to 0 and solve. We did the same thing last time, right? So x can't be 3 over 2. So you're just going to say where x cannot be 3 over 2. Okay, so the restrictions are only going to occur if you have a fraction. Okay, now these next ones are kind of fun. Now we're going to move on to evaluating. Okay, so before we were doing operations, when you evaluate, you're going to be plugging in each value, and this is called a composition. So I told you we were going to look at compositions today. You're given f of x is 2 to the power of x, and you are given that g of x is 7 minus x. We have to find each value. Okay, so when you are doing these, what you can do is work your way from the inside, and you can evaluate g of 4. Okay, so the first step is to find g of 4, and then we are going to substitute that back into our expression. So remember, when you're finding g of 4, all that means is you are plugging in 4 for what part of this equation? X. Okay, so instead of 7 minus x, we're going to do 7 minus 4, and we get 3. Okay, so if g of 4 is equal to 3, that's the same thing as finding f of 3. Okay, so you take that value that you found in step 1 and you substitute it into the equation. Okay, so now when you're finding f of 3, it's 2 to the x value, so 2 to the third. Okay, this is your f of 3. Okay, so your final answer here is going to be 8. Okay, so I want you to try that with part B. And I want you to do these without your calculator, but part B is a big number, so no, I didn't.
Went to the third square root of it.
All right, do you need more time for B, or are we ready?
No, we're ready.
Okay. So for your first step, your f of 4, okay, is just 2 to the 4th. So 2 times 2 times 2 times 2. So what's 2 times 2? 4. 4 times 2? 8 times 2? 16. Okay, so then we're going to find g of 16. So 7 minus 16 is going to be, what did you guys get? Negative 9. Great. Okay, so your final answer is negative 9. That is the final answer. Okay, and then for C, your first step is g of negative 3. So when you do minus a negative, did you remember to change it to plus? Good. Okay, and you got 10. All right, and then I know 2 to the 10th is kind of a lot. Sometimes you can think of it as like powers of powers. Like 2 to the 5th times 2 to the 5th, 32 times 32. Okay, and you should get 1024. Really, you can do that without a calculator. Like if you know 2 to the 5th off the top of your head, you can just keep doubling it, and it's not too bad. All right, now for part D, we're going to have to remember a few things about fractions and negative exponents. So your first step, when you plug this in, okay, I want you to remember if you have a negative exponent, to make it a positive. Do you guys remember this rule from Algebra 1? If you have a to the power of a negative, To make it positive, you can put it over 1. Yep, that's one of your exponent rules from Algebra 1. So this means you do 1 over 2 to the third. And 2 to the third is what? 8. Nope, that's if you have 1/3, the power of 1/3. So then we're going to do g of 1/8. So 7 minus an 8th. And for this, if you want to write it as a mixed number first and then convert it, you can. Because if you just subtract an 8th, you'd have 7/8 left, right? Yep, 6 and 7/8. 6 and 7/8 plus an 8th would be 7. And then, do you remember how to change it to a mixed number? Yep. So 8 times 6 is 48. 48 plus 7. Okay, so then your final answer is 55/8. Yes, I heard it. Okay. So we just did a composition of functions where you had to evaluate, but sometimes you're going to do a composition of functions where you are going to be plugging in a value. Okay, so for the composite function, we're going to be focusing on this in the domain. Okay. All right, so all 3 of these things up here mean the same thing. The way that you pronounce this is f of g of x. The way you pronounce this is f of g of x. It's not fog, even though it does look like fog. Okay, so this is f of g of x. That's how you say it. Okay, and then we're going to write down also what it means. Okay, I also don't want you to think that it means multiplication. Okay, so the way we say this is f of g of x.
All of them?
Yep, all of them. Yeah, f of g of x. With that, it's just implied. Okay, and then this is what it means. It means we're going to substitute okay, we're going to substitute g of x into f of x for x, okay, for the variable. So we are going to be substituting an expression into an expression. Okay, so f of g of x means we're going to substitute this g of x expression into the f of x expression. And we are also going to have to identify the domain. So when you're looking for restrictions with your domain, you're thinking, what values can I not plug in for x? So there are really, I said there were 3 things, but I kind of combined 2 and 3, so we'll talk about those together. So the first thing you want to watch out for are fractions. Because if you have a fraction, the denominator can't be 0. Okay, and so when I first did this, I just said like square roots, but it's really any even root. We're really going to just look at the square roots. Okay, so those are pretty much the same thing, and that's because you can't take an even root of a negative. Okay, you can't take an even root of a negative. Okay, so when that happens, that value underneath the square root is called a radicand, whatever is underneath there, if you can't take the even root of a negative, it has to be greater than or equal to 0. So we're going to be using that when we are finding the domain. Okay, so you are going to be given different functions. You have to find each composite and state the domain of each. When you state the domain, we're going to use set builder notation. Okay, so we are given 4 different expressions that we're going to be working with. Okay, and I'm just going to ask you to watch me with the first one, and I'll give you time to write it down. Okay, and then we are finding the composite, and we're stating the domain. So there's 2 different things that we're going to be finding here. Okay? All right, so when you have f of g of x, what that means is you are going to substitute g of x in for x. I'm just going to write substitute. You are going to substitute g of x into the equation of f of x. Okay, so I just want you to look at f of x. It's x squared minus 1. What you can do is you can rewrite that without the x in there. So x squared minus 1. Okay, so I want you to go ahead and do that step. So whatever function is on the outside, that is what you are plugging it into. And then instead of x, we're going to rewrite the g of x. So this is x over 1 minus x. All right, and then we are going to simplify. So when you have a fraction, you are going to square the numerator and the denominator. So this becomes x squared over 1 minus x squared minus 1. And then remember, you can FOIL that. So if you like to write it out as you FOIL, you can do that. You can write it in standard form. 1 times 1 is 1. Negative 2x plus x squared. So this would be x squared minus 2x plus 1 minus 1. Do you guys know why we can't cancel out your x squareds here? Yeah, because you have the negative 2x here and the plus 1. If it was just division, that would be fine. But here, because you have everything with that, there are these implied parentheses there when you have a fraction. Okay, so this is your composition. Okay, and then from there, you are going to find the domain. So with the domain, all you have to do is see if there's a fraction or an even root. Okay, here we do have a fraction. So the rule with a fraction is that the denominator can't be 0. Okay, so to find the restriction, you just set x squared minus 2x plus 1 equal to 0, and you solve. Okay, in order to solve this, you're going to factor it. Okay, so you have negative 1, negative 1. And then this is a multiplicity. It's okay if you just write it one time. Okay, and then your x value cannot be 1. Okay, so then your domain is just going to be x such that x cannot equal 1. Okay, if you were to plug 1 into the denominator, it would make it 0. So we have to exclude it from the domain.
So we have to factor it, right?
Well, if it's a trinomial, yeah. You could use your quadratic formula. Yeah. So you don't have to factor it every time. You could use the quadratic formula there. Okay, so for B, now we have these switched. G is on the outside, f of x is on the inside. So for your value of G, okay, we're going to look at, this is x divided by 1 minus x. So the first thing I do is I set up the function without the values of x. And then see if you guys can do the substitution there. Make sure you put that in parentheses, because you are going to have to do some distribution. Okay, so we should be plugging in f of x inside the parentheses. Okay, so you're going to have x squared minus 1 and x squared minus 1. Okay, on the top you don't have anything to simplify. You do have the difference of 2 squares, but let's see what's happening in the denominator. So when you distribute the negative, okay, you're going to end up with a negative x squared plus 2, and you can write this 2 different ways. You can either write your final answer like this, or you can write it like this. Okay, you probably see this sometimes in answer keys, because if the first thing is negative, they tend to just flip those around. Okay, it doesn't matter which way. Okay, but you don't have to worry about factoring if you aren't going to cancel anything out. So that's going to be your final answer. And again, we have this fraction. So if ever you have a fraction, you know that the denominator can't be 0. So we're going to set 2 minus x squared equal to 0 and solve. So see if you can do that and then write out your domain. Okay, and then you can start part C. All right, so you have 2 equals x squared. Take the square root, take the square root. So x is going to be plus or minus root 2. So for your domain, you're just going to say x such that x cannot be plus or minus root 2. Okay, and that's all you have to do. Okay, you're solving for x. You're putting those restrictions in that notation. Okay, you're going to see that part C is a lot simpler than those 2 that we just did. Okay, so we're plugging h of x into f of x. F of x is x squared minus 1. So when you plug in h of x, it's just a nice little binomial there. So all we have to do is FOIL Okay, and then negative 12 and negative 12 is negative 24x. (16 minus 1 will be 15. Okay, and then when you do your domain, the first one we had fractions. Okay, but is there a fraction here? No. Is there an even root? No. So then what is our domain? Yep, all real numbers. Do you guys remember how to write that in set builder? X such that? Yeah, X is an element of the real number set. Good. Okay, so then it's all real numbers. All right, so we will finish that tomorrow, and I'll give you your worksheet tomorrow. If you know you're not going to be here, just come and grab it, okay?